Today's topic is about writing inequalities or translating inequalities. We've done this with equations, we've done this with expressions, and now we're going to do the same thing where we're taking a phrase that's in English and we're translating it into a math statement or mathish. I think it would really benefit you if you would, in your journal, go ahead and pause this video and write down what you see here on the screen. To set up your journal with a double T chart, so something that looks like this, and then fill in this information. These symbols, less than, greater than, less than or equal to, greater than or equal to, are really going to benefit you if you understand how they work while you are trying to do this translating. These are also a couple of examples of word phrases that mean each of these inequality symbols. The ones that are the worst for kids to understand, the ones that tend to confuse them the most, are these: at most and at least. At most means that we have no more than a certain number. For example, if your mom was to tell you that you can have a birthday party, but you can have at most 10 guests. That would mean you could have 4 guests, you could have 6 guests, but 10 would be your maximum, which is also a word that we use for less than or equal to, maximum. So your maximum would be 10. On the other side of things, at least means greater than or equal to. So if in order to qualify to be in the National Junior Honor Society, your average must be at least a 90, that would mean that your average could be 90, it could be 94, it could be 98, but it could not be less than that 90. The 90 would be the minimum, which is also a good word for you to have in your journal. At most and at least almost feel like they're opposite of what they should be. So let's look at a couple of examples. Here, we need to write an inequality that represents this phrase here that's in quotes, and then we're going to graph it. So the easy part is right here, y minus 3. Well, with subtraction, of course, order matters. So this is going to be y minus 3 is less than or equal to negative 5. So now that we've done this, the next thing we have to do is solve. So the opposite of subtracting 3 would be adding 3. So I'm going to do that to both sides of my inequality. So then I'm left with y is less than or equal to negative 2. So on my graph, this is just like what we've been doing. I'm going to come to the negative 2. And because we have the equal to, this is going to be shaded in. So I'm going to color it in. And y is less than it, which means I need to shade in this direction. Let's look at this next one. The temperature of the river is greater than negative 1 degrees. So we don't know what the temperature is, so I'm going to use x to represent it. Is greater than negative 1. So I have my greater than symbol, which is a little sloppy. Let me fix it. Greater than, it's still sloppy, look at me. Negative 1. So that means I'm going to find my negative 1. But since it is a just greater than symbol, I'm going to use an open point. And it is greater than, so I'm going to shade in this direction. Let's look at one more situation. The weight of a package is at least 2.5 pounds. So I'm going to use W to represent the weight of the package. And I know that I'm going to have this 2.5 over here, but it's the at least that is the confusing part. So at least 2.5 pounds. So that means that the minimum that it can be is 2.5 pounds. Could it be more than that? Absolutely. So that means that W has to be greater than or equal to 2.5 pounds. Be really careful with that at least and at most.